Okay, hi, welcome. So we're in section 3. It's about using limit laws to evaluate limits. So the first law is the sum rule. If you're taking the limit as x approaches a of a sum of two functions, what this first law is saying, you can distribute the limit to the first function and the second function. So the limit of as x approaches a of quantity f of x plus g of x equals to the limit of f of x as x approaches a plus the limit of g of x as x approaches a. So for example, if they ask you to you're asked to find the limit as x approaches 1 of x squared plus 1 over x. So you're going to take this limits and distribute this to both functions. So you take the limit of x squared plus the limit of 1 over x as x approaches 1. So in terms of limits, you plug in 1 for x. So you get 1 squared plus 1 over 1, which will give you 1 plus 1, which is 2. The second law is the difference law. Only this time we have a difference of two functions. So again, you will have to distribute this limit to f, both f and g, and then take the difference of limits. So you have the limit as x approaches pi of sine x minus ln of x. So you will take the limit of sine of x as x approaches pi minus the limit as x approaches pi of ln of x. Again, you plug in pi for x. So you get sine of pi, which is 0, and then minus ln of pi. So the answer is negative ln of pi. So law number 3 is the product rule. If basically you're taking the limit as x approaches a of a product of two functions, then you will take the limit of f of x times the limit of g of x. So again, distribution of limits in terms of the product, multiplication. The limit as x approaches 0 of sine of x over x times cosine of x. So you take the limit of sine of x over x as x approaches 0 times the limit as x approaches 0 of cosine of x. We know by now that the limit as x approaches 0 of sine x over x is 1. And when we plug in 0 for x into cosine function, we get cosine of 0, which is 1. So 1 times 1 is 1. So law number 4 is about the quotient rule. Basically, when you're taking the limit as x approaches a of f of x divided by g of x, you can also take the limit of f of x as x approaches a divided by the limit of g of x as x approaches a, as long as the limit of the denominator is not 0. So here's an example. The limit as x approaches 2 of x cubed minus 1 over x squared plus x plus 1. So you're going to take the limit of the numerator divided by the limit as x approaches 2 of the denominator. And then you just evaluate x cubed minus 1 at x equals 2. And also you evaluate x squared plus x plus 1 at x equals 2. So you get 7 over 7, which is 1. Law number 5 is limit of a constant. So anytime you're taking the limit of a number, any number, the answer is always that number, regardless of where x is approaching. Okay. So the limit of a constant, we say, is a constant. The limit of 5 as x approaches negative 2 is 5. Law 6. The limit of x as x approaches a is a. So basically, x is a. Just plug in a for x, and then you get the answer. For example, the limit of x as x approaches 10 is 10. So just plug in a 10 for x. Law 7. The limit as x approaches a of x to the nth is equals to a to the n. So the limit of x squared as x approaches negative 1, so you plug in negative 1 for x and then you square it, so you get 1. This is a constant times a function law. So when you're taking the limit of a constant times a function f of x as x approaches a, nothing is done with, you can bring the constant, a constant is a number, so you can bring the number outside of the limits. So this limit will become the constant, which is c times the limit as x approaches a, or f of x. For example, the limit as x approaches pi over 2 of 2 times sine x. So you can rewrite this as a 2 times. So you bring 2 is a constant. You bring it outside of the limit. So to get 2 times the limit as x approaches pi over 2 of sine x. Again, you plug in pi over 2 for x. You get sine pi over 2, which is 1. 1 times 2 is 2. And then law number 9 is the limit as x approaches a of the nth root of f of x. So here, this is a case where we're going to bring the limit to the function, directly to the function. So we take the limit as x approaches a, we bring it under the nth root where the function is. And then you apply the limit to the directly to the function. So we are assuming that the limit, this the nth root of the limit as x approaches a of f of x must be defined. Okay. So an example, the limit as x approaches 0 of the square root of x squared plus 2x plus 3. So what we're saying is we're going to take this limit and then apply it directly to the function x squared plus 2x plus 3. So the limit goes under the square root sign. And then when you apply the limit, you take the limit as x approaches 0 of x squared plus 2x plus 3. Basically, you plug in 0 for x, you get under the square root, you get 3. And then you get the answer is square root of 3. So when you look at this example, you have the limit as x approaches -1 of the cube root of x cubed plus 2x minus 5. Again, you apply the limit directly to the function under the cube root. So when you take the limit as x approaches -1 of x cubed plus 2x minus 5, you plug in -1 for x. So you get -1 cubed, which is -1, minus 2, and then minus 7, which give us -8. The cube root of -8 is -2. So again, the limit as x approaches 2 of the fourth root of x squared minus 5x minus 2. Again, you apply directly the limit to the function. So you have the limit as x approaches 2 of 2x minus 5 minus 2. Plug in 2 for x. You end up with -8 under the fourth root, which is undefined because you cannot have the fourth root of a negative number. Law number 10. When you have the limit as x approaches a of f of x raised to the nth power, you can basically bring the limit directly where the function is and then raise everything to the power n. For example, if they give you the limit as x approaches 1 of quantity e to the x plus 3x plus ln of x all raised to the power 10, so you can just bring the limit directly to the function and then raise the whole thing to the 10th power. So when you take the limit as x approaches 1 over e to the x, it gives you e, and then over 3x it gives you 3, of ln of x it gives you 0. So you get e plus 3 all raised to the 10th power. Okay, so these are the laws. So that's law 10. And then I just did more examples over here. And so I think there is a continuation of laws, but we don't want to make this video too long. So what I'm going to do is for this video I will stop right here. Okay, so this is the end of this video right there. Thank you.